go ahead and pause the video and try these ones as well. So, detergent removing gravy from a garment in water. So this one's kind of tricky, so if you didn't get it, that's okay. So basically what you're looking at is that there's actually two things present here. Okay, and this is why detergent works. Detergent has a nonpolar end, and that nonpolar end will actually dissolve the nonpolar fats and greases that might be considered present in a stain. So the detergent's nonpolar end would be dispersion forces. The detergent's polar end would be ion dipole, because it would be the detergent and water interacting. And most of the time the detergent is going to have an ion present in there to be considered that. So this one's kind of a far-fetched example, just trying to show you that more than one intermolecular force can be there. Okay, so dissolving table salt in water. So we're going to go through our intermolecular forces practice. So table salt is a compound that's ionic. So when I look at my first example, an ion dipole intermolecular force, that is anytime you have a salt in water. And so because I have table salt in water, I can stop right there, and I know that this is an ion, and this is a polar molecule with water, so I have a salt with water, and I know that I have an ion dipole force. Alright, let's look at sugar in water. So I'm going to start at my first intermolecular force. If I've got an ion, if I've got a salt in water, I know it's an ion dipole force. Well, we know sugar is a covalent molecule, and so there's no way that this can be an ion dipole. My next intermolecular force is a hydrogen bond, and so I know that sugar does not have a hydrogen attracted to a nitrogen, oxygen, or fluorine on the water molecule. So I know it cannot be a hydrogen bond. I know that sugar, however, is a polar molecule, and I know that water is a polar molecule. So my next example, or my next intermolecular force, is a dipole-dipole, and because both of these are polar molecules, this is a dipole-dipole intermolecular force. Alright, lastly, let's look at the strength of intermolecular forces. So table salt versus sugar in water. So because I know that table salt in water is an ion dipole from our example, and I know that sugar in water is a dipole-dipole, I know that the ion dipole is going to be stronger than the dipole-dipole because my ion dipole intermolecular force is much stronger. So dissolving iodine and oxygen in water, which is going to be stronger? Well, because they're both nonpolar molecules dissolving, it's going to be dispersion forces, but iodine is more polarizable, which gives it a larger dipole, and so that makes it have a stronger intermolecular force. Okay, thanks for watching the example problems and writing it down. Hopefully you can come with questions to class next time.